Right, so stability, fact or fiction. We're going to make some example systems today and then determine the external or internal stability of them. So as a quick review, internal stability is stability with respect to initial conditions, and external stability is stability with respect to the input. So to start off, our first example is going to involve some calves that we have from a farm. So we're going to have a field, right? And then we're going to put a group of calves in the field. They're going to be chilling there, and that's going to be the system, that group of calves. Now the input into the system is going to be people, and when people walk up to the calves, the output will be the displacement of the calves from their origin. Okay, so in general, when people approach the cows in the system, the calves are going to walk away and be all skittish, right? That's how the system normally works, because the calves are afraid of people. So when we're testing the system for its external stability, we're going to go and we're going to put a small input into the system, one cow whisper, and see how the cows react to that. So we see here one cow whisper dB walk into the system, and the calves stay very still. They stay still for a super long time, and eventually even like approached him a little. So system is externally stable. Right, so the next system we're going to do is going to be pretty much the same as the first. We're just going to use sheep this time. So system sheep, input people, output displacement. In normal use of the sheep system, when people are inputted, the sheep will rapidly run away and displace. So we tested this system for external stability the same way we tested the sheep system before. The big difference is that the sheep system is way more sensitive to input than the calf system was. So we had to combat this, and to do that we made sure that the input for testing for external stability was super small. However, the sheep still immediately scattered when the input was applied and when the person approached the sheep. So the system is definitely externally unstable. Chickens were the next animal on the list, and we put them in the same basic system as the last two. Now, the chickens stayed relatively still when left alone and immediately ran away when approached by a person. We decided to test this system for internal stability. So, we took one chicken and changed its initial conditions and had 0 input put on it. We moved it away from the origin and waited. And, given a little bit of time, the chicken moved back to the origin and stayed there. This system is internally stable. The last two systems we show will be set up differently than the previous ones. For these, the system will be a cow, the input will be a push to the cow side, and the output will be the displacement of the cow. Now, if a great enough force is applied, the cow will move to the side, or, if applied quickly enough, it might even tip over. This system will be tested for external stability. The cow will start with 0 initial conditions, and we will approach the cow to apply a small force to its side. As you can see, this cow does not care about the input. This system is definitely externally stable. Now, we will perform the same test on a new cow and thus a new system. We will find the test for external stability to have quite different results on this new system. When the small force is applied, the cow has a large displacement away from the origin. This is an externally unstable system. Well, that's all. I hope this video has been at least somewhat helpful in understanding the general concept of stability.